everyone, welcome back to my YouTube channel. I'm Varsha from Sri Venkateshwara College of Engineering. Today we'll be discussing about the data flow diagram of ARM processor. ARM processor is basically the advanced RISC machines, that is RISC means reduced instruction set computing architecture, which is widely used in the mobile devices to supercomputers. The architecture is designed to be very energy efficient to make it an ideal for portable for devices with limited power resources. ARM processors are also known as the simplicity, low power consumption and high performance. The key features are that the two-term instruction set, which allows both 16-bit and as well as the 32-bit instruction, improving code density and performance. Trust zone technology that provides hardware-based security features to protect sensitive data and applications. Neon SIMD, that is single instruction multiple data engine, also accelerates multimedia and single processing tasks by performing multiple operations in parallel. Big literature architecture that combines high performance core with power efficient cores to optimum performance and power consumption. Let us look at the overview data of the data flow of the ARM processors, where the initial stage is fetch. During the fetch stage, the ARM processor retrieves the next instruction from the memory. During the decode stage, the ARM processor decodes the fetched instruction and determines the operation to be performed. During execute state, the ARM processor performs the operation specified by decode instruction. In memory access, the ARM processor accesses memory if required by the executed instructions. The write back stage, the ARM processor writes and reads the executed data that is based on the appropriate registers or memory location. In fetch stage, the fetch stage is the first stage of the ARM processor where the instructions are fetched from the memory and prepared for execution. Steps involved in the fetch stage are the program computer. The program counter, that is PC, is incremented to point to the next instruction address. The instruction address is sent to the memory management unit, that is MMU, to translate the virtual address to physical address. The physical address is then sent to memory unit to fetch the instruction from the main unit. The fetched instruction is stored in the instruction register, that is IR, for decoding and execution. The next stage is the decode stage of the ARM processor, which is responsible for decoding instructions and preparing them for execution. This stage follows the fetch stage and precedes the execute stage. The decode stage involves the following steps. Decoding the instruction. The instructions fetched by the memory is decoded to determine the operations of the performed and operand involved. Register file access, that is the decode stage, accesses the register file to read the value of the registers that are used as operations in the instruction. Operand preparation, that is the decoded stage, prepares for the operands for the execution stage by performing any necessary data conversions or calculations. The branch calculation is that if the branch of the instruction, the decoded stage calculates the branch target address based on the branch offset and the current program counter. Control signal generation. Decode stage generates the control signal that specifies the operand performance, the execution state and the control data flow with the processor. Then the execute stage, that is the execute stage of the ARM processor, is responsible for executing instructions and performing calculation. This involves the following steps, that is to fetch the instruction from the memory, decode instruction, that is the fetched instructions in the decoded to determine the operations to be performed. Perform calculation. The processor performs the necessary calculation based on the decoded instruction. Then to store the data, the result of the calculation is stored in the appropriate register of the memory. The next stage is the memory stage of the ARM processor, that involves accessing and manipulating memory. This stage is an essential part of the processor's operation as it allows the data to be stored, retrieved and modified in the memory. The fetched data. In the memory stage, the processor fetches the data from the memory. The data can be instruction or operand needed for the execution of the program. The store data. The processor can also Store data in the memory. This is useful for saving intermediate results, storing data for later uses. Modified data. It allows the modification of the data in memory. This can involve performing arithmetic and logical operations on the data. The final stage is the write back stage, that is which is the result of the executed instructions are written on the back of the memory and register. We have only two steps over here: write result to memory, write result to register. In write result to memory, if the instructions had modified memory, the results are written back to the appropriate memory locations, and write results to the register. If the instructions has modified registers, the results are written back to the appropriate registers. So I conclude this presentation by highlighting the crucial role of database in the ARM processor ecosystem. By understanding the data flow with this architecture, we gain insight into the seamless interaction between the processors and the database, emphasizing efficiency and optimal performance. As the technology involves, the robust understanding of the data flow in ARM processor becomes increasingly important for developers as well as engineering work to enhance the capability of the modern computing system. Thank you.